Hey there, science fans! Welcome to an incredible journey into the microscopic world that forms the foundation of everything we see and touch. Have you ever wondered what makes up everything around us? From the tallest skyscrapers to the tiniest grains of sand, every single thing is composed of the same fundamental units. From the air we breathe to the food we eat, it all comes down to tiny particles called atoms. These atoms combine in countless ways to form the diverse materials and substances that make up our world. These little guys are the building blocks of matter, and understanding how they interact is the key to unlocking the secrets of chemistry. Imagine them as the Lego bricks of the universe, each with unique properties and abilities to connect with others. But don't worry, chemistry doesn't have to be intimidating. It's a fascinating subject that can be both fun and enlightening. With a bit of curiosity and the right approach, anyone can grasp the basics. In this essay, we're going to break down some basic concepts in a fun and easy-to-understand way. We'll use simple analogies and engaging visuals to make complex ideas more accessible. So buckle up and get ready for a wild ride into the amazing world of atoms. We'll dive deep into the heart of matter and explore the incredible interactions that govern the physical world. We'll explore concepts like valency, atomicity, and electronegativity, which are fundamental to understanding how atoms bond and interact with each other. These principles are the foundation of chemical reactions and the properties of materials, and you'll see how these principles play out in everyday life. From the batteries in your gadgets to the food you cook, chemistry is at work all around us, making our lives easier and more interesting. By the end of this essay, you'll be able to impress your friends with your newfound chemistry knowledge. You'll understand the basics of how atoms work and how they come together to form the world we live in. So let's get started and uncover the amazing secrets of atoms together. Let's start with valency. Valency is a fundamental concept in chemistry that helps us understand how atoms interact with each other. It's like the social life of an atom, dictating how it bonds and forms relationships with other atoms. Think of an atom like a tiny friend with little hands outstretched, ready to connect with others. These hands represent the atom's ability to form bonds. Each hand wants to hold another atom's hand, creating a bond. This is how atoms form molecules, by sharing or exchanging these hands or electrons. The number of hands an atom has is its valency. This number tells us how many bonds an atom can form with other atoms. For example, oxygen has 2 hands, a valency of 2. This means it can form 2 bonds with other atoms. It loves holding hands with 2 hydrogens, each with a valency of 1, to make water. This is why water is H2O, with 2 hydrogen atoms bonded to 1 oxygen atom. Valency helps us understand how atoms combine to form molecules, which are just groups of atoms stuck together. These molecules can be simple, like water, or complex, like proteins and DNA. It's like a big, happy atomic dance party. Each atom finds its partners and forms bonds, creating the diverse and fascinating world of chemistry we see around us. Understanding valency is key to unlocking the secrets of how everything in the universe is built. Now let's talk about atomicity. This concept is fundamental in understanding the behavior of elements and their interactions. This fancy word simply refers to how many atoms of the same element are hanging out together in a molecule. It's like counting how many friends are in a group. Sometimes, atoms of the same element love being together. Take oxygen, for example. Oxygen atoms are like social butterflies. Oxygen in the air we breathe exists as O2, meaning 2 oxygen atoms are stuck together like best friends. They form a strong bond, making them inseparable in nature. Other elements, like helium, prefer to be alone. Helium atoms are more like lone wolves, enjoying their solitude. They have an atomicity of 1. This means each helium atom exists independently, without needing to bond with another atom of its kind. Understanding atomicity helps us predict how elements will behave and react with others. For instance, knowing whether an element prefers to be alone or in pairs can influence how we use it in chemical reactions and industrial applications. This knowledge is crucial in fields like chemistry, materials science, and even medicine. By grasping atomicity, we can better manipulate elements to create new materials, develop medications, and understand the natural world around us. So next time you think about atoms, remember that their social preferences, whether they like to stick together or stay apart, play a big role in the world of science. Finally, let's talk about electronegativity. Imagine 2 atoms sharing electrons, which are like tiny balls of energy. Electronegativity is how strongly an atom attracts those shared electrons. Think of it like a tug of war. Some atoms, like oxygen, are really strong and pull those electrons closer. Others, like sodium, are weaker and don't have as strong a pull. This difference in electronegativity is what makes chemical bonds interesting. It determines how electrons are shared between atoms, influencing the properties of the resulting molecules.